Okay, so we've looked at the formula for area of a sector. The first couple of examples are basically just plugging numbers into formulas. So we'll run through them fairly quickly. So I've got to find the area of a sector. The radius is 2.44. Given that the sector subtends an angle, forms an angle of 1.4 radians. So our formula is the area equals half r squared theta. So I just need to plug in the radius, which is 2.44 squared, and theta, the angle. So grab my calculator, and then half 2.44 squared and 1.4, and I'm going to get an area of 4.17 centimeters squared, because we go to three significant figures. Bear in mind, although we need to be working in radians, it actually doesn't make any difference on the calculator whether you're in degrees or radians at this point, because we're not actually doing any of the trig functions. So these rules work when we're in radians. If we were given the angle in degrees, we'd have to do some converting. But if we're given the angle in radians, we can just use these formulas on the calculator and not think quite so hard about it. Example 12. Very similar sort of question. Again, we need to use that the area is half r squared theta, but this time we're given the area and we're given the angle of 0.8 radians. In the diagram, the area of the minor sector. Remember that minor sector means that we're dealing with this sector here, and this one here is called the major sector. Okay, because both of those sectors are essentially formed by the same angle. So we're given the angle, calculate r. So now I know that 28.9 equals half r squared times by 0.8. So I could just do a little bit of rearranging. So r squared is going to be 28.9 divided by 0.8 and then multiplied by 2. So if I want r, then I just need to square root all of this lot. So I can plug that in one go. If you'd rather plug numbers in first and then do some rearranging, that's absolutely fine. It doesn't really matter what order you do this in. So r is going to be the square root of 28.9 divided by 0.8 multiplied by 2. And then it's 17 over 2. And always better to leave things as a decimal, so 8.5 centimeters. Still pretty straightforward, just plugging numbers in. Example 13 is a little bit tougher. There's a little bit more involved in this, and this is closer to what you might see in an exam style question. I've got a plot of land in the shape of a sector, so let's just first start by sketching that out. I've got a sector here. The radius is 55 meters, and the length of fencing, so I'm just going to make a little note to myself. Fencing around the edge is the same thing as perimeter. Enclosing the land is 176 meters. Calculate the area of the plot of land. So I don't seem to be given very much information. I've only got lengths here, but actually we can do all of this. The first thing to do is just to look at this and go, well, if I know the two radii and the whole perimeter, I can find the arc length pretty easily. It's going to be 176, take away the 2 radius, so take away 110. So we're on a 66 meter arc length. And actually what I really need is I really need to know what theta is, the angle. Because if I know the angle and the radius, area is easy. And I have arc length. So the arc length is r theta. We know the arc length, we know the radius. So 66 equals 55 theta. So theta is 66 divided by 55, or 1.2. So I have an angle of 1.2 radians. And now the area is just half r squared theta, which is half of 55 squared times by 1.2. So let's just plug that in the calculator. Half of 55 squared times by 1.2 is going to give us an area of 1,815 meters squared, and we're done. It's not too tricky, but you do have to work through it step by step, and we're always asking ourselves the question, what information do I have, and therefore what can I find out next? What's the next thing I can fill in? Even if I can't get to area straight away, just let's plug everything down on paper, and what's the next step? What can I do next?